Hello, my name is Gabriel, and welcome to a new episode from Concierge OS. In this episode, in preparation for playing with tools, we would like to make some changes. This section from model settings will be promoted into a setting here in the menu. There, we should be able to set the VLLM base path. And when we press this fetch model info, it should fetch the currently loaded model as it does here. And then this model will be reused throughout the application. So both in the performance tests and in guest search or reservations or whatever. So this will make things easier for us, and we don't have to reuse model settings every time we play with performance tests. And this page will be smaller. In order to validate the capabilities of Gemma4, I will continue using it for this development because I'm curious about the coding comparison with Qwen. It is significantly faster even comparing with the mixture of experts Qwen version. So I have created a prompt and a plan for this refactoring. The conclusion that I have until now for the coding capabilities is that it is significantly worse than Qwen. It gets stuck pretty often in these loops where it tries to fix errors, but it is not trained to go thoroughly in understanding the reason of the error. It is very fast, but it just skims the surface. So this gives us an insight about what to expect when using it in frontend. It will for sure be very fast in retrieving information and making tool calls. It is not a good model if we will have prompts that involve multiple steps. It will get somewhat stuck. It also seems to struggle understanding the full picture. Here it tries to use Flask and blueprints, but this is a fast API project, so settings.py will not work. This looks like a dangerous model for vibe coding. It presents a plan, but then it introduces a lot of other things. For example, it introduced Tailwind. I'm not actually sure if it will work or not, but now it exists. So create a new page with a model. Wow. Oh yes, a very big difference from Qwen. No, I don't like this model for coding in any way. This is my conclusion so far. So personal opinion of mine about live code bench. That I'd never looked at it, but that must be a very easy benchmark if this model could score 77%. So I have loaded Qwen and I gave it the same code base. We not revert anything, and I just told him that the previous plan introduced bugs and that it should go and fix them. And indeed, it identified the correct problems. Note that this is the same smaller Qwen model, not the very big one. The biggest problem that I see is in the way they perceive work and how much they try to go in deep with what exists and go on from there. Gemma did not try to do that at all. Probably another test later on would be to take Gemma4 31B and compare it with Qwen27B. I still expect Qwen to win, but I'm curious if the problems that what I'm trying to compare here is Gemma4 26B with Qwen 35B. Indeed, Gemma has less parameters, but then it has more active ones. It has 4 billion active and Qwen has only 3 billion active. Although it has more active parameters, it is obvious that it is not reasoning inside as much as Qwen does. It could be that fast because it just outputs everything. Now that Qwen fixed the code, regardless, so the server is still running, and let's refresh the page. Well, okay, all the damage has been addressed. Now there is this settings tab here that fetches the model correctly. Then we can set things here as we save them. We can go to the performance tab and everything is cleaner. Now that we are done with the refactoring and the fixing, the first thing that we would like to do in this episode is to implement tool calling for the retrieval data from the database. This is fairly easy. There is a key in the JSON. There should be a list of tools as such. Then there is the implementation of the actual tool. And in the response, in the client, in the request that we make, we pass the list of tools, and then the model will call them as it sees fit. So what we have to do is to implement general tool for database interaction, specify it, and pass it along. Now there are two layers of this tool calling, and it depends a lot on us how we would like to handle it. First problem is that in the system prompt, we should also describe the schema of the database, because if we just tell the model, hey, look, this is the tool that returns the information, it will guess the field names, possible values, so on and so forth, relationships, etc. So this should go in the system prompt, and then the tools will be called based on the prompt of the user. So we have to do the two layers part. This is what I was afraid of. We do not want to handle create and update and cancel. We want to handle just read operations. By handling updates, that's how you open the Pandora box of database deletion in production. We will have to refactor this functionality because the system prompt that goes into guest search and the system prompt that goes into tool calling should be one and the same. I do not like that tool calling re-implements what we already have, and the database structure is not loaded based on the pedantic models which we already have. It is nice that this smaller Qwen spits out a lot of code really fast. I prefer the slower models which pays more attention to how things are structured. Now we are aligned on what we want to achieve. Okay, let's see what happens. So we run the server, no errors so far. We open the web page, we refresh. We have performance page, and if we take one of the guests and we go for guest search and we search for it, I expected a tool call. Many fixes later, and now we have tool calling. So I'll close. So we can refresh and see that it is working. We also have a button now to display the debug information. Maybe here we can include a thinking part. What is interesting is that even when using Qwen, we got to almost the same speed as when we were using Gemini. The cache hit is very high, which is super good, and the information is very accurate. Now, I think we lost this functionality. If we search here, I am unsure if it will use both first name and last name in a query. It's doing 2, 3, 4. Okay, I'm impressed. And this is very good that it is working. Now for the performance tests, in order to appreciate the difference, we should add a new way of running the performance test for multi-guest. Yes, this configuration stays the same, and in data format, instead of XML JSON, we should add a new data format, which is tool call. And let's run some tests with tool calling with both models to see the difference between the two. Let's try the first run with tool calling. It's strange that it ran that fast. Let's see. Last batch. Yes, it did not have time to fetch the answer from the model. Probably it initiated all the calls, but did not have time to fetch them. So this run can be deleted. We should add a button here to delete the selected batch. Delete button has been added and confirm that it is working fine. Now we need to investigate why performance test for tool calling doesn't work. We know for sure why it's not working. It is because the way the tests work now, they send a request, but they don't take into account that this request will come with tool calls that have to be resolved before moving to the other request. This bug has to be fixed, and then it should work. So by asking nicely, we did get an analysis, and yes, we were correct. The tool calling was not handled at all, as expected. The suggestion is good. It says that it should reuse the already existing function from toolcalling.py instead of re-implementing it. So yes, we'll go with option 1. Yes, we want to reuse it. Like this, we also test the same functionality. manually, and then it should be working fine. The server is running. What we want to do now is to rerun the test with tool calling. We can better see the difference between how it was working in the past and how it is working now. Now it has a lot of internal communication with the completion endpoints because it keeps asking for information from the server. There is less token generation, but more communication. Still, it's significantly faster than how it used to be before. Now, running requests in parallel, this changes things a little bit because right now it will put way more load on the server than it does on the LLM itself. Previously, all the load was on the LLM because we had the data ready. Now, every query for a new user creates a couple of requests on the server. So this is a very big difference. We shift the load from the LLM to the server. Let's see how the last one behaved. Good. So we still have one empty response. We are still not over with the errors. What we can do now, we have the luxury of implementing a retry mechanism in this case, because things are fast enough to be able to actually do it. For sequential, we have 4 guests, but we don't seem to have information about the reservation. So this one has reservation details, this one does, this one has 4. Okay, this is good. This one has, this one no, and this one, 2, has some, but not enough. So now since we allow the LLM to decide by itself what it should retrieve, we have a little bit of more control. We can improve the queries that happen on the database to retrieve all the information, or we can let it fully handle this situation by itself. Now it starts to make sense to have another layer in between our database and the LLM functions as a caching mechanism. So we can have the expensive queries in the database on SQLite and have Redis-like instance in between that keeps all the guest informations already indexed by guest. We can have them indexed by guest and we can have them indexed by reservation, for example. Keeps them all as a string. And in that case, the LLM will handle the translation of the name of the guest, will hit that layer first, which will either bring back all the information or an error, and only after it will hit our server if it doesn't find the information in that cache instance. So we already have improvements, but significant improvements in terms of speed. Even with Qwen, we have managed to significantly lower processing. If we compare to what was the best for probably JSON for Qwen. So we went from 30s to 80s to 10 to 30. So it's a significant improvement. What we should do now is let's see how Gemini handles the same test, and also let's see how the smart Qwen handles this, because now since everything is so small, even the smart Qwen I expect it to be rather fast. Go for tool calling and run new tests. Personally, I'm very curious about the difference between this bigger one and the smaller ones when it comes to tool calling, because I expect the tool calling to level the playing field a lot. We should ignore the first one because it warmed up the cache inside the LLM, so it doesn't count. I still have an argument that the smarter model can perform less queries on the database and should return things faster, but it is to be seen. Good. Now this is the moment of truth, the second one. So already it is significantly slower than the faster Qwen. The prefix cache hit rate for the bigger model is a lot higher than for the smaller model, but it doesn't really matter because the generation speed is so slow that it loses any advantage it has. Still, with tool calling, comparing this bigger model with the same version of bigger model, even if we take into account the fastest data type, it's still half. I think the best that happened for guess number 2 in the other test was 120. Now it's faster, it's 92, the output. I'm curious if it will manage to bring all the reservations for all the guests, even in concurrency mode. I would like to be able to test what the bigger model brings from the database. If it brings a bunch of users or just some, because the prefix cache rate is insane. They are not even, so smaller one had 23 something, 25 at best, 28. There you go. The bigger one has 80, in the high 80s, almost 90s. And also the KV cache usage, 50s. Okay, this one. There is also a very big difference between the two when it comes to KV cache usage. Here we are talking about 7, 8%, 9%. And in case of the smarter one, 50. So if we manage to find a model, so now I'm very curious about the outcome of the bigger one. The performance that we see here can easily be improved with hardware. I do wonder if the big model is doing name translation also. Another type of test that we should implement after we progress more with this project and we make it more useful is to take these translated names and feed them to the LLM in a Latin language, and there see how many of them are being retrieved by each model. I think this big model fetches more users than expected because the cache rate has hit 100% and then the eviction process has started. I'm curious if the last few concurrent guests will be able to finish their work. We are already into prompt processing territory again. Honestly, too bad. If we were to use only 5 users instead of 8, the speed would have been perfect for concurrent. Let's see the outcome. So we select the last run. Oh, still an error. This is amazing. Maybe there is something wrong with the data. We'll have to investigate further. Guest 1, guest 2, guest 3, guest 4. Check. Okay, this is not good. It did not finish. This is correct. I'm not sure because it doesn't contain the last. These don't contain the last sentence anyway. Okie dokie. So there is improvement. The last test is to see Gemma. Gemma finished loading. Okay, let's run test for Gemma now. Things are arriving in VLLM. It still seems to be fast, but I'm not really sure if it will be faster than just feeding everything. In the next episode, we will do the refactoring of all the project. We will make it tidier and we will also add a front-end framework to make our life easier. And if there will be time for the performance tab, we would like to create a comparison between batches. So thank you very much for watching and see you in the next one.